My name is Mike Reed from REDMAK Pop-Up Studio, and this is my second film in a series that is intended to assist architecture students with their construction studies. The first film looked at the placement of insulation in the external envelope, and the conclusion was that it needs to be in the outer skins of the building. The other conclusion that we arrived at was that the breathability of the different layers of the construction needs to increase as you move out through the building. In other words, the outer layers need to be the most breathable. The inner layers can have a high resistance to vapor. So what I'm drawing for you is a section through an external wall construction that would appear to contradict the breathability issue, in that we're going to clad this external wall with zinc, obviously for its weatherproofing characteristics. Now what that means is we're going to put a sheet of material which is non-breathable as the outer skin, and that's the conflict with the decreasing vapor resistance as you move through the outer layers of the construction. So zinc is a non-self-supporting sheet of metal, and it needs a sheet of plywood to fix to. So here's our layers of fairly standard construction, starting on the inside with wet plaster. And I say wet plaster as opposed to plasterboard because wet plaster bonds directly to blockwork without an air gap, which means the plaster and the block contribute to the thermal mass of the building. The blockwork represents the structural zone of the building. It could be masonry, there could be steelwork, columns and beams in that same zone. Outside of that masonry there are vertical studs creating an insulation zone, and this could be a low efficiency insulation like mineral fibre. The stud creates a cold bridge, so we clad externally to all of that construction with a high performance insulation, a closed cell board. We're going to be creating a gap in our construction here, and I'll come on to the reason for that gap in a moment. But that gap is created by a batten there with plywood fixed to it, and then we're going to clad that plywood with zinc. Now the reason I'm saying there is a gap in here is because the zinc closes the external envelope of the building and prevents the vapour from getting away, the vapour from us living in buildings, breathing, making coffee, having showers. So at the bottom of the wall there needs to be a ventilation route into that cavity, and at the top of the wall there needs to be a ventilation route out. What that means is that the air that is in this cavity is the same air that is outside. Any moisture that works its way through the construction into that zone ventilates away rather than condensing on any of the construction materials. So it's not normal for us to draw our details in 3D like I've drawn. So I'm going to draw an example of this in the 2D way that is normal for contractors to use. Blockwork with plaster, a stud zone with insulation in it. Remember, this is the low efficiency insulation mineral fibre. This one is the high efficiency closed cell type insulation. And I'm intentionally drawing a break in the construction here so that I can show you the ventilation at the top and bottom. Because there's masonry on the inside of this insulation, a vapour barrier is not required, but a breather membrane is. That dashed line is the breather membrane. This is the vertical batten, which is holding the plywood, and the zinc cladding is there. At the bottom of the wall there will be a drip formed in that zinc cladding. At the top of the wall there would be something like a parapet, maybe clad in zinc. At the bottom of the wall there's a ventilation route in. At the top of the wall there's a ventilation route out. So that is one example of a wall that conforms to the ideals of the first film. Lots of masonry on the inside creating high thermal mass building, insulation near the external side of the envelope, and decreasing vapour resistance to the materials until we get to this one, which is why we've got ventilation in behind it. Thank you for watching.